We've got these incredibly powerful AI models, right? They seem to know pretty much everything. But what happens when you need to teach one a brand new trick, something it has absolutely no clue about? Well, today, we're going to dive into a quest to teach an AI a new skill completely from scratch.
So that's a big question, isn't it? Can an AI really learn a totally new skill? And I don't mean just getting a little better at something it already knows. I mean starting from absolute zero. Can you take one of these jack-of-all-trades AIs and turn it into a master of one very specific, very niche craft?
And this is where we really see the AI's blind spot. You know, if you ask it to whip up a diagram using something popular, like Mermaid or Plant UML, it's a piece of cake. It does it perfectly. But then ask it to use a less common language, something like Pintora, it just stares at you blankly. It has no idea what you're even talking about. It's a total beginner.
And that, my friends, brings us to our mission. We're going to follow along with an experiment to teach an AI this exact niche language, Pintora, right from the very beginning. The goal? To make it so good that it can create brand new diagrams and even edit existing ones, all on its own.
Okay, so first things first, on any teaching journey, you gotta find the right student. It's time to pick the perfect AI model to be our, let's call it, our digital apprentice for this whole thing. So the selection process had a couple of hard rules. First off, the model had to be under 30 billion parameters. That was mostly just a practical thing, due to the hardware they had. And it needed to be a model that was actually built for coding. So after looking at the options, the choice was made, Quenn 2.5-Coder 7B. Yeah, it's a bit of an older model, but still super capable for this kind of job.
All right, now to be absolutely sure this model was a true blank slate, that it knew nothing about Pintora, it was given this super simple prompt. Just a straightforward request to see if it had any hidden knowledge. And the result? Oh, it was a spectacular failure. The model tried its best, but it spat out a diagram in a completely different language, Plant UML, which you can tell by that @startUML tag. This was perfect. It proved without a doubt that our apprentice had zero knowledge of Pintora. It was ready to learn.
So this brings us to the next, and honestly, maybe the most critical hurdle in this whole project, the data. I mean, you can't teach a new skill if you don't have any textbooks, right? The question was, how in the world do you find or create a good data set for a language that basically doesn't exist out there on the web?
The first idea was, let's just make the data by hand. Yeah, that lasted for about 5 examples before it became obvious that would take forever. So next up was searching GitHub for any Pintora code that might be floating around. That only turned up a few examples. Another dead end. It was time to get creative.
And here was the breakthrough. It was the realization that if you can't find the data, you can just create it. And how? By using other, bigger AIs. By giving models like Gemini and Claude these super detailed prompts, it was possible to generate thousands of really good Pintora code samples to use as our training material.
Now, the data that came out of these other AIs wasn't perfect, not by a long shot. It was messy, it had tons of duplicates, and a lot of the code was just plain wrong. So a big cleanup was absolutely essential. A script was written to merge all the duplicates, and then a validation tool went through every single piece of code, testing it and tossing out anything that didn't work.
After all that scrubbing, what was left was this beautiful, clean data set of 1,500 high-quality examples. This was then split into 2 key piles. A bigger set of 1,000 for the first phase of learning, and a smaller, more focused set of 500 for the detailed instruction part.
All right, we've picked our student, and we've written the textbooks. It was finally time for class to begin. This is where the magic happens, the active training phase, where we take all that curated data and use it to build this brand new skill right into the model.
The training itself happened in 2 separate phases, and it's actually a lot like how you and I learn a language. Phase 1, pre-training, was like learning the alphabet and grammar, just feeding the model raw Pintora code so it could learn the basic rules. Then phase 2, fine-tuning, was like learning to write sentences, teaching it how to actually use that grammar to follow specific instructions.
Of course, it wouldn't be a real-world project without a few hiccups. Pretty quickly, the training process started hitting out-of-memory errors on standard GPUs, the 16 gig kind. This meant they had to upgrade to a much beefier 48 gigabyte GPU just to finish the job. It's a great little reminder of the real, practical challenges you face when you're doing this stuff.
So after all that work, choosing the model, painstakingly creating the data, running the training for hours and hours, we finally get to the moment of truth. Was the mission a success? Did our little AI apprentice actually learn its new skill?
The answer? Well, it can be summed up in one number, 86%. An 86% success rate, which is awesome. But what does that number actually mean?
So that 86%, that represents something called syntactic accuracy. Here's how they tested it. They gave the model almost 1,000 random prompts to generate brand new diagrams, and out of all of those, 857 of them were functionally perfect. The code worked, it could be turned into a real diagram without a single error. That is just an incredible result, especially from such a small amount of training data.
And here's the proof. You can see it in action. The model could successfully create a diagram from scratch just based on a new instruction, and, maybe even more impressively, it could correctly edit an existing diagram. It didn't just memorize the grammar. It actually learned how to apply it.
So, look, this was a really successful and, let's be honest, a really fun experiment. But what's the bigger picture here? Why does teaching one AI, one little niche language actually matter? Well, what this whole experiment proves is that creating specialized AI is more accessible than it has ever been. You don't need a giant team and a massive tech company anymore. With some clever thinking about data and a focused training plan, it's totally possible to customize smaller models for these super specific tasks. And that just blows the doors wide open for a future full of personalized AI tools built for any purpose you can dream up. And that kind of leaves us with one final thought. If you could take an AI and give it any unique skill or expert knowledge, I'm talking anything, from a forgotten programming language to the complex rules of a board game, what would you teach it? Because the tools to actually do it, they're now within our reach.